All right, hi folks, this is Larry Mussolino. I'm recording a video for Module 8 in Math 181. And this has to do with sample spaces, events, and calculating relative frequency. So what we'd like to do here is understand how to set up a sample space. A sample space is really going to be all the possible outcomes for an experiment. So here it says sample space is the set of all possible outcomes. For example, an experiment might be flipping a coin. Then the sample space would be heads, tails. Those are the only possible outcomes when you flip a coin. If I was rolling a die, the sample space would be 1, 2, 3, 4, 5, or 6. Those are the only possible outcomes of what could happen when I roll a die. If I was picking a card out of a deck, there would be 52 elements in the sample space because those would be all of the possible outcomes corresponding to picking any one of the 52 cards. All right, now why do we want to know about the sample space? Well, it's going to help us with probability calculations, especially in the next module. So over the next few modules, we're going to be working with probability calculations. For that, we're going to need to know the sample space. All right, one other consideration is what is an event? Well, an event is some subset of that sample space. So let's say we go back to rolling a die. The sample space is 1, 2, 3, 4, 5, or 6. What about if the event I'm interested in is rolling an even number? Well, that event corresponds to the subset rolling a 2, 4, 6. Those are the even numbers from the sample space. Here's another example. Let's say I'm in the market for a new car. Here are the cars I'm interested in: 4-door Camry, 2-door Fiesta, 2-door Altima, 4-door Maxima, 2-door Miata. I could think of this as the sample space. Those are all the vehicles I'm considering. What if the event is I want to investigate a 2-door vehicle? Well, that event would be the subset from the sample space of these 3 2-door vehicles. All right, well, besides an event, we can also think about the complement of it. The complement is all of the elements in the sample space that are not associated with event A. So if my event A was selecting the 2-door vehicles, remember here was set A, the complement of A, we usually write that as A with an apostrophe, we say A prime. A prime would be all the other car models other than 2-door vehicles. So the complement A prime would be the 4-door vehicles: 4-door Camry, 4-door Maxima. All right, well, you might remember we talked about union and intersection before, so let's revisit that. The union is taking the set of elements that are in one set or the other. So we write it as A, U, B. So this U symbol means union. So you remember what you do there is you take all the elements from both sets and combine them together into one larger set, but you don't repeat any elements. So if this was set A and this was set B, and I wanted to form the union, I would combine all of those different elements together. Okay, remember you don't repeat elements in any set. Here's one more example. Set A here are the students taking calculus. Set B are the students taking physics. I want to know what is the set of students that are taking calculus or physics. That's really going to be the union. So the union is going to be the elements that are in set A or B. And so I would put together all of these students that are in both sets A and B. Notice I'm not duplicating because Susie showed up in both set A and B, but when I write the union, I only list Susie one time. All right, so again, we don't repeat any elements in a set. Well, there's also intersection in 2 sets. The intersection means outcomes that are in common to both sets. Sometimes we use the word and. The intersection is A and B. It means I'm looking for any elements that are in both set A and B. So let's go back to calculus students and physics students. Well, the intersection would be students that are taking both calculus and physics at the same time. So what I'm going to do is look for students that are in both sets. Well, I'm noticing Susie is in set A and in set B. So Susie's going to be in the intersection. Bill is in set A, set B. Bill goes in the intersection as well. Okay, so when it comes to union, think of the word or. When it comes to intersection, think of the word and. Here's a good video from Khan Academy. Please check those out. All right, one more bit of terminology, mutually exclusive events. These are events that have no outcomes in common. Another way to think about it is there's no element that's in both set A and B if they're mutually exclusive. Another way to think about it is if you form the intersection, there would be no elements in the intersection. We could say the intersection is the empty set. Okay, so here's an example. This is set A, numbers 2, 4, 6, 8, 10. Here's set B, numbers 1, 3, 5, 7, 9. Notice there's nothing in common, no elements in common between these two sets. We would say these are mutually exclusive events. All right, so we're going to use sample spaces and events and knowing how many outcomes are in an event. We're going to need that when we go and calculate probabilities a little later. All right, one more item I wanted to mention here is this notion of relative frequency. Relative frequency is really understanding how frequently an event occurs relative to the total number of observations. Okay, here's an example. Let's say you are thinking about getting knee surgery. You say to the doctor, what's the probability that a knee surgery will be successful? Because if you're going to go in for knee surgery, you want to know, is it highly likely to be successful or is it maybe not that highly likely? Well, the doctor would probably go back and look at historical medical data. And maybe out of the past 200 knee surgeries, they noted that 194 of them were successful. Well, that's going to be the relative frequency. I'll take the number that were successful, 194, divided by the total observations, 200. I get 0.97. The conclusion is there's a 97% likelihood or probability that a knee surgery will be successful. So the formula to use here, where P parenthesis E means the probability of event E. Of course, it's up to you to define what event E is. Event E might be a successful knee surgery. Event E might be rolling a 6 on a die. Event E might be, selecting a king from a deck of cards. Event E might be selecting a Ford electric vehicle. So let's do a quick example of relative frequency based on a table of data. So here's a table of electric vehicle sales showing the number of vehicle sales for Ford, Chevy, Toyota, Tesla. Ford wants to know what's the relative frequency that an electric vehicle that's sold is a Ford brand. Well, I'm going to set up a fraction to find the probability that someone will buy a Ford electric vehicle. Let me take the number of the frequency for that event. Well, there were 34,000 Ford electric vehicles sold divided by the total, right? The total number of observations. I'm going to add up the numbers in this column. If you add up these numbers, it turns out to be 340. 34 divided by 340 is 0.10. So the relative frequency here is 10%. So it means there's only a 10% likelihood or a probability of 10% that a new car buyer that's going to buy an electric vehicle will select a Ford. All right, so let's go ahead and do some WebAssign examples from this Module 8. And there's going to be a couple of different kinds of problems. You'll see there'll be ones that ask you to count up the number of events in a sample space. There'll be other problems that ask you to calculate relative frequencies. So let's go to WebAssign. Bear with me a second. All right, folks, I'm here in WebAssign. So I'm looking at the Module 8 homework. Let's work through a few of these. Let me go to number 1 here. It says, consider the following: 3 coins are tossed, and the result is at most 1 tail. All right, first it says, which of the following are included in the sample space? Well, ask yourself, if you toss a coin 3 times, so there's, three coins are tossed. Let's say here's coin 1, here's coin 2, and here's coin 3. How could I set up a listing of all the possible outcomes for this experiment of tossing 3 coins? Well, I know this is going to be a heads or a tails. This is going to be heads or tails. This is going to be heads or tails. So there's 2 ways to fill in the first box, 2 ways to fill in the second, and 2 ways to fill in the third. It's going to be 8 altogether. Well, there's a little bit of a shortcut to write all these out. What you do is you start out with the first coin. I know there's going to be 8 rows in this table because there's going to be 8 possible outcomes. So I'm going to make the first 4 be heads and the last 4 be tails, because I'm looking for an organized way to write out all these 8 outcomes. Let me go to coin 2. What I do now is I write heads, heads, tails, tails. So I'm alternating 2 coins at a time. And then for coin 3, I just alternate 1 coin at a time. So it'd be heads, tails, heads, tails, heads, tails, heads, tails. So this gives me an easy way to write out all 8 outcomes. I could have all 3 heads. When I flip the 3 coins, I could have all 3 tails or any of these outcomes in between. So this is listing out all the possible outcomes. All right, let's go to part B. It says list the outcomes in the event. Well, the event they're talking about is at most 1 tail. So I just got to be careful. What does it mean to say at most 1 tail? Well, at most 1 means less than or equal to 1. Less than or equal to 1 means there could be 0 tails or there could be 1 tail. So at most 1 means either a 0 or a 1. So I'm going to select all of these outcomes that have either 0 or 1 tail. Well, this has 0 tails here. This has 1 tail. This has 2 tails, so I can't select this one. This has 1 tail. This has 2 tails. I can't select this one. This has 1 tail. This has 3 tails, so I definitely don't want to pick this one. And the last one is 2 tails, so I'm not going to pick that one. All right, so I just had to be careful here with the interpretation of the word at most. At most really means less than or equal to. All right, let's take a look at another problem. All right, let's take a look at number 3. It says here you're considering purchasing a domestic car, imported car, van, antique car, antique truck. Which of the following are elements in the sample space? Well, the sample space are really all of the possible outcomes of what I could purchase. So I'm just going to list out domestic car. Here's domestic car. Imported car. Here's imported car. Van. Here's a van. Antique car. Here's antique car. Antique truck. Here's antique truck. I'm not going to pick domestic truck because that wasn't on the list of my purchasing options. I'm not going to pick imported truck. That also is not on my list. So I'm just picking the list, the items that were in my sample space. All right, now it says list the elements in the given event. Well, my given event was I'm not going to buy a car. So I can't include a car. But remember, I can only pick from the sample space. So what I'm going to do is go back to the sample space and pick any non-cars. So I have an antique truck. Yep, that's a non-car. So antique truck is good. A van. Yep, a van is in the sample space and it's not a car, so I'm going to include van. Antique car, that's in the sample space. But remember, I don't buy a car, so I'm not going to pick an antique car because no car is being selected. And then domestic car, but I'm not going to pick a car. Imported car, I'm not going to pick a car. So these are really the only 2 answers that are in the sample space and correspond to the event of not buying a car. All right, let me do another one. How about if we go to number 5 here? It says, let W be the event that you use a book's website tonight. I is the event your math grade will improve. E is the event you'll use the website every night. Write the given event in symbols. All right, either your math grade will improve or you'll use the website tonight, but you will not use it every night. All right, so let's try to fill in with letters here. When they say your math grade will improve, that's the event I. So this is really an I. You'll use the website tonight. Well, that's the event W. Now the word or is a union symbol. So remember, the word or is union. The word and is intersection. Remember, an intersection symbol is an upside down U. Well, I'm going to put a U here for the word or. And notice here there's a comma saying I now have to consider this other one. And it says, this is really like an and statement, and you will not use it every night. Well, I know using it every night is E, but it says not use it every night. So this is really the event E prime, or the complement of E. And the word and is an intersection. So by translating this sentence, we come up with this answer here. Okay, so again, the word or, think of as a union symbol. The word and, think of as an intersection symbol. All right, let's go down. Let's take a look at this one here. This one's giving us a table of results. And here are the events they're talking about here. They say S is an author is successful, U is unsuccessful, N, the author is new, E, the author is established. And here's some data that has been collected shown in the table. All right, now here they say S intersection N. Well, I know intersection is the word and S is the author is successful. The letter N is the set that the author is new. So really, when I go to this drop-down menu here to pick my answer, successful and new is the correct answer on that one. All right, how about S-U-N? Well, U is union. So this is going to be successful or new. So if I go down to this drop-down, successful or new. Okay, so again, I'm just interpreting the words. I'm interpreting that a intersection symbol is the word and, the union symbol is the word or. All right, now it says let's compute them. Remember, the N means cardinality. So how many elements are in the set successful and new? Well, to be successful and new, you would have to be an author in this box right here. So successful and new is 14. All right, how about successful or new? Well, this one's a little tricky. You might remember from a past module, we said that if you want to know successful or new, you take the number of successful plus the number of new, but that double counts. We've got to subtract out the number of successful and new. All right, let's figure out the number of successful. Well, the number of successful is really this row. All of these authors are successful. So that's 24. What about the number of new? Well, the number of new are all the authors in this column. These are all the new authors. Well, that's 18. But notice how I just double counted 14. So 14 is in the blue row, but it's also in the red column. So I just double counted 14. Well, I've got to subtract out that double count. And 14 is the number of authors that are successful and new. But you remember this was the formula where we have to subtract out that successful and new to avoid the double count. So if I work this out, this works out to be the number 20. All right. Let's do a few more. How about if we look at number 8 here? So for 8, they're telling me it's the same setup. S is author successful, U unsuccessful, N, the author is new, E, the author is established. And now they're saying describe a U, the event U, union E prime. Well, I know U means unsuccessful. Union is the word or. What about this E prime? Well, this is the complement of E. Right? Well, E is the author is established, so E prime would be non-established. So really this translates to unsuccessful or not established. So you could see this is the answer right there. All right, now it says find the number of elements. All right, well, if we want to find the number of elements in the set U, union E prime, it's going to be the number of elements in U plus the number in E prime, but I got to subtract the number in the intersection of U and E prime. All right, well, let's go to U. This is the number of unsuccessful authors. Well, that looks like 66 total. So this is going to be 66 total. All right, what about E prime? Well, E prime, these are the established authors, but I don't want established. I want not established. Well, really, that's new. So really, E prime, so this is E. That means E prime is this column. So E prime, I'm going to select those, but that adds up to 23. So this is a 23, but I got to subtract the intersection. Well, notice the number 14 is in both the row and the column. That's the intersection. So I got to subtract that out. And if you work this out, this works out to be the number 75. Okay, so again, this was an OR type of calculation. And to find the cardinality for a union, you take the number of elements in one set plus the number of elements in the other set, but you got to subtract the number in the intersection. Remember, this is the double count part of it. So we got to subtract out that double counting. All right, let's do a few more. What if we go to number 11? This is a little different because this is asking us for relative frequencies. All right, well, the first thing it's asking me to do here is fill in this empty box. What number should go in this empty box? Well, you might remember the sum of the relative frequencies must add up to 1 in a frequency distribution like this. So the sum of the relative frequencies must add to 1. So the numbers they're giving me are 0.1, 0.4, 0.3, 0.1. Let's call this X. That's kind of the unknown. So if I add these together, that is 0.9. The red numbers add up to 0.9. So 0.9 plus X has to equal 1. So the missing box, the empty box, must be 0.1. All right, now they want me to compute the relative frequencies. So they're asking me to compute the probability of 2, 3, and 4. Well, that's just asking me to add up the relative frequencies when X is 2 plus X is 3 plus X is 4. Well, this is going to be 0.4. That's X equal 3. So this is going to be 0.4 plus. We need X equal 2. Let me start that again because I guess I should have done. Let's do this. So this is really going to be the probability when X is 2 plus the probability when X is 3 plus the probability when X is 4. Probability for X is 2 is 0.1. The probability when X is 3 is 0.4. And the probability when X is 4 is 0.3. So if I add these together, I get 0.8. All right, let's go down to part B. It says, what is the probability of the complement of E, where E is 3, 4? Well, that means the complement must be all the other elements other than 3 and 4. So that's going to be 1, 2, and 5. So if I work that out, that's going to be the probability for 1 plus the probability for 2 plus the probability for 5. And it looks like each one of these happens to be 0.1. So this adds up to 0.3. All right, let's look at a few more. How about if we look at number 13 here? All right, well, they're asking us just to calculate relative frequencies for each one of these events: current, past due, in foreclosure, repossessed. Well, all I have to do here is remember the formula for the probability for using relative frequency. It says take the number of outcomes for E and divide by the total number of observations. All right, so let's do it for current. The probability for current would be the number of current, which is 136 from the table, divided by the total number in the table. So I'm going to add up all the 4 numbers in the table. If I do that, I'm getting 200. So this is 136 divided by 200, which is 0.68. All right, let's do one more. How about probability of repossessed? Well, that would be the number of repossessed, which is 3 from the table, divided by the total number of observations from the table. 3 divided by 200 is 0.015. Here's a question. It says, what's the relative frequency that a randomly selected subprime mortgage was not current? So here they're asking me the probability of the complement of current. Well, really, one way I can easily do this is just take 1 minus the probability it is current. So that's just 1 minus 0.68. That's 0.32. Another way I could have thought about this question is I could have said the probability for the complement of current must be any event that's not current. So this would be the probability of past due plus the probability of in foreclosure plus the probability of repossessed. And I know these probabilities because I just calculated them. Past due was 0.28. Foreclosure was 0.025 and repossessed was 0.015. If you add these up, you get the same answer, 0.32. All right, so this is calculating relative frequencies. Let's see here. Let's go number 16. So here's a table. And again, they're showing us successful, unsuccessful, new versus established authors. Here it says we want to know an author is unsuccessful and new. So they're asking me what is the relative frequency for unsuccessful and new? Of course, I could think of this as the intersection. I got to be careful. This is not an or, this is an and. So for and, both of these conditions have to be true. Well, here are the new authors. Here are the unsuccessful authors. So to be new and unsuccessful, you would have to be in this cell right here, which is 32. So the probability of unsuccessful and new is that number 32 divided by the total. The total from the table is 200, so 0.16. All right, so for the and relative frequency, I'm really looking at the number at the intersection of the row and column that was specified. All right, let's see if there's anything else that's a little different. What if we go to number 18? Number 18, I think, is a little different. All right, it says a random sampling of chicken in supermarket shows 70% was contaminated with an organism. So contaminated is 70%. Okay. It says of that contaminated chicken, so of that 70%, 20%, so let me write here, 20% had a strain that is resistant to antibiotics. All right, so here's what they want me to figure out first. Probability of U. Well, this is the probability the chicken is not infected. So we want to know the probability the chicken is not infected with the organism. Well, I know that they told me that 70% of chickens were contaminated with the organism. Well, that must mean this should be 1 minus 70%, right? If 70% are contaminated, 1 minus 70% are not contaminated. All right, let's go to part B. Part B says, what's the probability that the chicken is infected with a non-resistant organism? So probability the chicken is infected with the non-resistant. Well, let's think about this for a second. I know that of the 70% that contaminate, 20% are resistant. That must mean the other 80% are not resistant. So for a chicken to be infected with non-resistant, really they have to be contaminated first and not resistant. So really what I could do here is multiply these two probabilities together. So this is the probability that a chicken is contaminated, and this is the probability that it's not resistant. So this is 0.56. All right, let's go to part C. The chicken is infected with the chicken is infected with the resistant. Well, in that scenario, I'm coming down this path. So the probability that a chicken is infected with the resistant organism and this is like an and probability, because for this to occur, the chicken would have to be contaminated and would have to have a resistant strain. So this is going to be 0.7 times 0.2, 0.14. Okay. So coming down this way, this red loop was the probability of R that we just calculated. Going down this green path was the probability of C. Right, where C was this, the chicken is infected with the non-resistant organism. All right, maybe we could do one or two more. Let's see what's a little different. All right, how about if we come here to number 22? All right, this one says, so this one's giving me a table where there are different kinds of companies, pharmaceutical, electronic, internet companies. And this is the performance of stocks after 1 year, okay? So there are some stocks that increase, some stocks unchanged, some stocks decreased. All right, how about an internet stock that did not increase? Well, that really means they would have to be an internet stock and, remember the word and is intersection, they did not increase. Well, increase is V, so not increasing would be V prime. All right, now they're asking how many elements are in this event. They're not asking me for a relative frequency now. They're just asking me to count up the number of elements. All right, well, let's think about this. First, we need, so we want I intersection V prime. Well, here's column I. All right, let me think about V prime. Well, I know this row is V. So V prime are the other rows. You know, if it didn't increase, it either was unchanged or decreased. So I'm looking between the overlap for the rows I just circled in red and the column I just circled in green. Well, those are the number of stocks, 6 plus 2. So 8 stocks altogether as the answer. All right, folks, I think that covers most of the types of questions. I hope this helps you get started in this module web assignment. Please let me know if you have any questions.